Welcome back to All This Math. Since you're here, hit the like button. Go ahead, just hit the like button. All right. Also, subscribe to the channel if you're not already subscribed, and share this video with at least one other person. And also, if you have any comments about the video or about the content, please put them in the comment section. Also, if you have any questions about anything that I attempt to explain, please put that in the comment section also. All right. And also, I want to give a shout out to Historically Black College, Norfolk State University, located down in Norfolk, Virginia. All right. Now, 2/3 compared to 1/2. All right. Now, I'm going to show you a couple ways. Well, actually, three different ways that we can compare fractions. One is what I call the Malcolm X method, right? Malcolm X method, which some people call the cross product method or the cross product property, multiplying diagonal numerator times denominator and this numerator times this denominator. All right. So let's go ahead and do that. What's 2 times 2? 4. So you take that 4, right? And you write it above the numerator that you just multiplied by. So you put it right here. And then you do 3 times 1, which is 3. You write that above the numerator that you just multiplied by again. Put that 3 up there. Then you compare those products. You ask yourself, which number is bigger, 4 or 3? 4 or 3. We know that 4 is larger than 3. 4 is larger than 3. So then we say, okay, if 4 is larger than 3, then 4 is associated with or is written by which fraction? It's written by 2/3. So therefore, 2/3 is greater than 1/2. 2/3 is greater than 1/2. All right. So you put your greater than sign like that. 2/3 is greater than. The open part of the sign faces the larger value. The open part faces the larger value. All right. Open part faces the larger value. The pointed part faces the smaller value. In this case, 1/2 is smaller. We can say 2/3 is greater than 1/2, or you can read it the other direction. 1/2 is less than 2/3. 2/3 is greater than 1/2, or 1/2 is less than 2/3. All right. Now, another way to do it, decimal conversion. You can either on paper, you can write out, you can do some division. You can divide 2 by 3 using any of the different methods of division and come up with a decimal. You can divide 1 by 2 using any of the methods of division and come up with a decimal. Or you can just have memorized fraction and decimal equivalents. Like you could just know that 2/3 is equivalent to 0.67 because it is approximately. 2/3 is equivalent to 0.67. And 1/2, think about half of a dollar. Half of a dollar is 50 cents. 1/2 is 0.5. Now, this has 2 digits after the decimal point. So in order to compare this more easily, let's make sure this has 2 digits after the decimal point. So there's nothing written after the 5, so we can use a 0 as a placeholder and just put a 0 right there. So now I'm comparing 67 hundredths with 50 hundredths. How many hundredths? I got 67 hundredths because the furthest to the right place that is occupied is the hundredths place. Over here, because we wrote this 0 as a placeholder, the furthest to the right place that is occupied is also the hundredths place. So we have this many hundredths versus this many hundredths. So I got 67 compared to 50, which is bigger. 67 is more. So 0.67 or 67 cent, think about it in terms of money. 67 cent is more than 50 cent. So that's going to be greater, right? 67 cent greater than 50 cent. All right. That's the decimal conversion method. Now, or you could have used your calculator. We could have did 2 divided by 3 on the calculator, and we would have got 0.6666666 until it stopped, until you ran out of space on the display. And then it would have rounded. The last 6 would have been a 7, right? And then 1 divided by 2 would have just gave us 0.5, right? So we would have got this anyway. But my point is that you should begin to memorize the equivalence between fractions and decimals, especially the like more popular fractions like 2/3 and 1/2, 1/4, 1/5, 2/5, 3/5, 3/8, 2/8, 1/8. Some fractions you'll see over and over. They're more popular than others, right? You know what I mean? Just like certain cartoons or that your children may watch are more popular. Like Sonic is pretty popular, right? So you know what I'm saying? So you should memorize certain fraction and decimal equivalents. 2/3 is equivalent to 0.67. 1/2 is equivalent to 0.5. You know. All right. Now, last but not least, LCD. Find the LCD. That's the fun part, right? The LCD is something that you're going to need to have in order if you ever want to add or subtract fractions, right? Because we can't right now. If we wanted to add these two together, we can't add thirds and halves, right? And this is 2/3, not 2/3. Don't call this 2/3. Don't do that. That's a bad look. Don't call it 2/3. Don't call this 1/2. Don't do that. This 2 tells you how many thirds you have. Because what does a fraction mean? This fraction means that you take this denominator and you had an object, right? Could have been a circle, could have been a rectangle, could have been a square, could have been a group of people, could have been anything, right? But whatever it was divided up into 3 equal parts. 3 equal parts. The denominator, the bottom number, tells you how many equal parts that object, that group, or whatever it is divided up into. Equal parts. Emphasis on the word equal, heavy on equal, right? The numerator tells you out of those parts, how many you care about or how many you're focused on. Focused, right? We're focused on 2 of those 3 parts. That's what 2/3 means. How many thirds are you focused on? I'm focused on 2 of them. That's what 2/3 means. So that's why we don't say 2/3, right? We say 2/3 because 2/3 is how many thirds I am focused on, how many thirds I care about. All right, then we go over here to 1/2, right? 2 is our denominator, right? That means we have halves. How many halves do we have? We have 1 of them. We have 1/2. 1/2. How many halves? 1. So we take an object, divide it up into 2 equal parts. 2 equal parts. Object divided into 2 equal parts. How many parts are we focused on? 1 of them. 1 of them. 1 of them. So we got 1/2. All right. Now, we want a common denominator, so we wanted to add these together. We couldn't because we got thirds and we got halves. It's like apples and oranges, right? So we need a common denominator, meaning we need to figure out if we went to LCD, right? The least common denominator. We want to figure out what the smallest number is. This is like a game, like a puzzle, right? Think of it that way. That's what makes it fun. That's why it's fun to me. What's the smallest number that both 3 and 2 can multiply into evenly with no decimal, no leftover, no remainder? I would say 6. Why do I say 6? Because I know that 3 times 2 will give me 6. And I know that 2 times 3 will give me 6. So 6 is the smallest number that the 3 and 2 have in common. In common. That's the C from LCD, in common, right? And these 2 numbers are denominators. So every letter in the acronym LCD has a meaning. L stands for least, C stands for common. What they have in common. What do they share, right? They have a 6 in common because 3 times 2 will give you 6 and 2 times 3 will also give you 6. So the common denominator is like a meeting point. Like a meeting point. It's like a meetup. Like meet me here, right? Let's meet up at 6, right? 6 is the smallest number where they can meet up at. So what we're going to do is we're going to create equivalent fractions, except these fractions are going to have a denominator of 6. So this 2/3 is going to become a new fraction with the same value though. The same value, but different numbers. The same value, different numbers. That's what makes it equivalent. It's got the same value, but with different numbers though. All right, draw another box just like that box. The 1/2 is going to turn into an equivalent fraction with a denominator of 6 because 6 is our LCD, right? That's the number that 3 and 2 have in common, right? Where they meet up at. They meet up at 6. So now the question is, what are my numerators going to be though? If my denominators changed, what are my numerators going to change into so that I'll have equivalent fractions? If the 3 turns into a 6, ask yourself, how did the 3 turn into a 6? And this is where knowing your multiplication facts comes into play. The 3 turns into a 6 by multiplying by 2. 3 times 2 will give you 6. Now, here's the trick. Not a trick, but here's the method. If I multiply by 2 on the bottom, I got to multiply by 2 on the top. If I multiply by 2 on the bottom, I got to multiply by 2 on the top. Whatever I do down the bottom, I got to do at the top. That's how this works every single time. When you're finding the equivalent fraction after you found the LCD, whatever I multiply by on the bottom, 3 times 2 gave me 6. I got to do the same thing on top. What's 2 times 2? 4. So that means that 2/3 is equivalent to 4/6. 2/3 is equivalent to 4/6. So instead of having an object divided up into 3 equal parts, I focus on 2 of them. Now I got an object divided up into 6 equal parts, and I'm focused on 4 of them. And actually, all I did was I took each of these parts that I was each of these 3 parts, and I cut them in half, and I created 6. Just like when you get a pizza, you get a large pizza, it's got 8 slices. If you cut each slice in half, now you got 16 slices. So you have 16ths. Same concept. All right. Now, this 2 turned into a 6. How? By multiplying by 3, right? So if I multiply the bottom by 3, I got to multiply the top by 3, right? What's 1 times 3? 3. 3, 6. Now, this was 1/2. Isn't 3 half of 6? See how it makes sense? 3 is half of 6. So now I can compare because I got common denominators. Common denominators. Now I can compare because why? Because look, how many sixths do I have? I got 4. How many sixths do I have over here? I got 3. What's more, 4 or 3? 4 is more than 3. 4 is more than 3. So that means that this is greater than this. So that's another way to prove that 2/3 is greater than 1/2, because 4/6 is greater than 3/6, because 4/6 is more than 3/6. So 4 of this thing, in this case, the thing is a sixth. A sixth is a thing, right? It's like a dollar is a thing, right? It's like if you had $4, that's more than $3. The denominator can be thought of as like currency, like money, right? And that's also why when you start adding and subtracting fractions, you never actually add or subtract the denominators. You keep them the same because the denominator is like this. And this is a very key point. The denominator tells you what thing you have, right? So if I have $3 plus $4, I'm not going to say I got $7 dollars. You don't add the word dollars to the word dollars and say dollars twice, right? The same thing with adding and subtracting fractions. Your denominator just tells you how many equal parts you have, right? So you only say that one time. So if you add 2/5 plus 3/5, that's why it's never going to be 2 plus 3 and then 5 plus 5. You just say the 5 one time because that's your denominator. So it will be 5/5, not 5/10. I repeat, it will be 5/5, not 5/10. You never add the denominators. You never subtract the denominators. You multiply the denominators or you divide the denominators in a division problem, but you never add or subtract the denominators. Remember that. All right, write it down, memorize it. You never add or subtract the denominators. Keep that in mind. All right, so these are the 3 ways that I taught you how to compare fractions with 2/3 and 1/2. So practice with that. All right, and as you see fractions just in everyday life, ask yourself which one is bigger, which one is smaller. Right? You can use these 3 methods. Use the Malcolm X method, cross multiply, convert them into decimals, right? Or think of an LCD. Think of an LCD is good practice because when it's time for, again, when it's time for you to add or subtract fractions, which we will have to do, right? You'll already know how to do it, because the most difficult part for a lot of people with adding and subtracting fractions is finding a common denominator, right? So practice finding common denominators like we did here. Think about the common denominator as a meeting point. It's the meeting point. Like, where do these 2 denominators meet up at? Where's the closest place they can meet? They can meet at 6. That's the closest place. That's the lowest. The lowest place is the closest place. Lowest place is the closest place. Lowest place is the closest place. Closest place is the lowest place. They can meet up at 12 because 3 times 4 is 12 and 2 times 6 is 12. But that's not the lowest place or the closest place, right? 6 is lower than 12, right? Yeah. They also could meet at 18 because 3 times 6 is 18 and 2 times 9 is 18. So they both also meet at 18. Think about, there's so many numbers where they meet up at. They have so many common denominators, or what we really call common multiples. This is what we really call them. But because they're in a fraction, we call them common denominators. So a common denominator is just a common multiple in a fraction or in the denominator of a fraction. All right. So make sure you like the video. If you didn't already, hit the like button. Subscribe to the channel if you're not subscribed already. Share this video with at least one other person. At least one other person. Somebody needs to know how to do this, right? I guarantee you, it's a lot of people that don't know how to do this, don't know these methods, aren't that familiar with them. And this is an important skill because it helps us to understand the language of fractions. Fractions are a large part of mathematics. Fractions are a large part of life, right? Large part of everyday life. We don't realize it. A lot of people, like, if you don't understand fractions, then, you won't recognize it because you don't understand it. But once you understand it, it's going to change your whole perception on the world, because you're going to say, oh, that's what that is. Okay. I promise you. Right. Also, drop a comment down below. If something didn't make sense to you, or something did make sense to you, drop a comment. If it did make sense to you, drop a comment. If it didn't make sense to you. And if you have a question, put your question in the comments. All right. Once again, shout out to Norfolk State University down in Norfolk, Virginia, and all the HBCUs. I'll see you on the next video. Peace.